Hello friends, here in this video we are going to discuss about Bernoulli equation. Now the question is, what is Bernoulli equation? Bernoulli equation is the form of equation which can be reduced to the linear differential equation. So it is not in the form of linear differential equation, we have to reduce it into the linear differential equation. So let's see the form of this equation. So the form of this equation is like that: dy by dx plus py is equals to qy to the power n. This is the form of Bernoulli equation. Here we have a dependent variable with degree n at right hand side of this equal sign. Since we don't have any variable at right hand side of equal sign in a linear differential equation, so this is the Bernoulli equation. And linear differential equation is like dy by dx plus py is equals to q. So here we don't have any variable at right hand side of this equal sign. So this is a linear differential equation because the derivatives of dependent variable has degree 1, and also their dependent variable has degree 1. So that's why it is called linear differential equation. Okay, and we can reduce it into this form. So the question is how we can reduce this Bernoulli equation into the linear differential equation. Now, since this is called the Bernoulli equation and we have extra variable in at right hand side of equal sign, here y to the power n, so we have to remove it from this side. So what we can do? So we can divide each side by y to the power n. Then from this side the y to the power n will be removed. So let's see. So let's write this equation again. Then dy by dx plus py is equals to qy to the power n. Now let's divide by y to the power n both sides. Then we get 1 by y to the power n dy by dx plus py by y to the power n is equals to q. And that is implies 1 by y to the power n dy by dx plus, this can be written as py to the power 1 minus n, that is equals to q. Now using substitution method, let's substitute this y to the power 1 minus n terms as z equals to y to the power 1 minus n. So let's differentiate z with respect to independent variable x. Then we get dz by dx equals to 1 minus n into y to the power minus n into dy by dx. So from here we can find dy by dx. Okay, so we get dz by dx is equals to 1 minus n by y to the power n into dy by dx. So from here dy by dx equals to y to the power n by 1 minus n into dz by dx. Now substituting this whole values, that dy by dx and z in this equation, let's named it as equation 2. Then we get equation 2 will be implies 1 by y to the power n. In case of dy by dx, we can put this value y to the power n by 1 minus n into dz by dx. Then we get y to the power n 1 minus n dz by dx plus p, since we assume z equals to y to the power 1 minus n, so we can write pz and that equals to q. And that implies, since yn and yn cancel out, so here left 1 by 1 minus n dz by dx plus pz is equals to q. Since 1 minus 1 by n is divide these terms, so let's multiply 1 minus n terms at both sides. Then we get dz by dx plus 1 minus n pz is equals to 1 minus n q. And this is the form of linear differential equation where p and q are either constant or it is the functions of independent variable x only. So we know that from linear differential equation. Now we get it, the whole linear differential equation of the Bernoulli equation. Now the question is how to solve this question. It is simple, since we know how to solve linear differential equation. So using that method of solving linear differential equation, we can solve as well this equation. So that's the Bernoulli equation and how to reduce it into the linear differential equation. If you like this video, then please like, share and subscribe. See you soon in a next video. Until then, peace. Bye bye.